this is Joe, RGF's Technical Support Manager, and today we're going to unbox the REMI Halo LED, show you what is contained in it, what you're going to be using for your installs, which we will be covering at a later time. First, on the top, you're going to find your accessory kit. This is going to include all of the stuff that you're going to be using when you do the install. As we see right on the top, we have a pair of UV light stickers. These are to be put on your air handler to inform anyone who happens to open it that the power must be turned off because the UV light is damaging to your eyes. Next, we have the gasket for the halo itself, the REMI LED halo. Warranty registration card. A little flyer. A little product information card, and your install instructions. We also have, this is your seal to seal around the unit after it is installed into the ductwork. We also have a relay. This is going to be used in most installs. This is a 2-position relay which has a normally open and a normally closed set of contacts, which you will be using in most installs. It's a 24-volt relay, so it is going to be activated by a 24-volt signal. And then we have a few wire nuts and a few screws to mount the relay and to mount the transformer. So we're going to move this to the side and show you what else is in the box. This is the REMI Halo LED unit itself. This is a directional airflow unit. As you see on the sticker on the top, it tells you your airflow has to be in this direction from the bottom up. And then in the bottom of the box, we have our power supply for the unit, which is a 24-volt transformer, a 40 VA. This unit can be wired for 120 volt, 208 volt, or 240 volt, depending on your air handler install you are using. Today we are installing the REMI LED unit into a standard electric heat air conditioning unit. So the first thing you need to do is you are going to mount it into the supply plenum above your air conditioning unit. The LED unit comes with a gasket, but you have to make sure, because the gasket has a certain shape to it, this shape normally wants to have the diamond point up, and you have to pay particular attention to the airflow on the LED unit. If you notice, there is a small arrow here. This arrow goes with the airflow. So on this particular unit, the airflow is up. So as the airflow is up with this particular unit, it will be mounted in the ductwork in this orientation. So if it is mounted in this orientation, you need to make sure that your gasket that you are using actually fits correctly on the unit as it goes. I am going to use this gasket as a template to make where I'm going to cut the hole in the ductwork. Again, remembering that it has to sit in this orientation, the flat on the bottom, the arrow up, and with the airflow pointing up, this is our orientation. So I'm going to set it on the ductwork here, trying to keep it somewhere near the center and square. And then I'm just going to draw a line around on the inside of the gasket template, to which we are going to cut out with a duct knife. Alternatively, if you were doing this with metal ducting, you could use a 4.5-inch hole saw, which would make it much simpler than trying to cut this particular shape in metal ductwork, as you do not want any sharp edges here on your metal ductwork to come into contact with the LED unit and cause problems. So you will just remove the blank you have. This is your basic hole. And then you can take your gasket, peel it off. You can also alternatively install this gasket directly onto the REMI LED unit and then put the whole entire unit, gasket and all, up here. Or you can do it such as the way I am doing it, this way. Your unit will stick up here itself. It comes with a aluminum tape gasket, which we are going to attach around the unit to keep it in space and sealed. The aluminum gasket that we use with it, you're not going to be using the center of this, just the outside edge of it. This is basically your final seal of the unit. It is a little problematic to use this gasket seal, and I normally tape with regular silver duct tape after I've done this, because most of the time I do not get this gasket perfectly correct. But if you take your time, you can pretty much get it aligned so that it seals between the edge of the metal upon the REMI LED and around the rest of the unit. In all instances, it is much preferred to have the unit installed in the supply. However, when that is prohibitive, that you cannot physically fit it into the supply, then you can mount it in the return. You will lose a slight amount of efficiency of the unit doing such. But again, if you have no room to install the unit into the supply, then it must go in the return. On this type of ductwork, you do not need to use any type of screws or whatnot to seal the unit, as the aluminum tape and the gasket will hold it perfectly fine. On metal ductwork, however, you may want to use the 3 screw holes around the unit, here, here, and here, to mount it to your metal ductwork for a more secure fit and install. You can, however, do the same type of install with your metal ductwork. Try to keep your aluminum tape clear of the cover, because the cover does remove if you need to service the unit, and you do not want the metal tape getting in the way of the unit. This is actually a perfectly good seal here, so I am not going to use the aluminum tape on this one, because I have a good solid seal all the way around, and we do not need to worry about that. That is the basic install of the REMI LED unit into the ductwork. So that is the easy part. Now we're going to move on to opening the air handler and doing the electrical wiring. First things first, always disconnect your power. On this unit, we're disconnecting it right here. It does have a disconnect as well, but this is a good positive disconnect for the power. Never work on a unit while it is energized. This is a standard air conditioning unit. So in this particular unit, we are going to use our relay, our 2-position relay, which has the normally open and normally closed contacts. We're going to use our transformer which comes with the unit and power it up through the unit itself. We're going to use the relay to cycle the power on and off for the transformer as the blower turns on and off. So we need to find a position to mount both the transformer box and the relay. As far as the relay goes, I am going to use one of the existing holes here in the air handler to mount the relay. I'm only going to use one of the holes in the relay, but alternatively it would be much better to use two of them. On the relay, you will be able to see in a moment, there are 5 connections, 2 of which are low voltage for the coil of the relay to cycle it on and off. And we are going to cycle those through from the existing thermostat in the unit. So as I have the relay positioned here, you have terminal 3 and terminal 1. We're going to connect terminal 1 to the yellow wire connecting to the thermostat, which powers the condenser that will cycle the relay every time the outside unit turns on, and it will close the contacts between terminals 4 and 2. We're going to feed our power through this relay from terminal 2 and out terminal 4 to our transformer. The transformer has its wiring color code on the top of the box, so you need to understand which power you are going to be using. This particular unit is a 240 volt air conditioning unit, so you are going to be using, according to our transformer color code, we are going to be using the black as the common wire, and as the 240 volt, the orange. The other 2 wires in here we are not going to be using. We need to isolate them. 240 volts needs to be your black wire and your orange wire, not your red. So these are going to be our line incoming, the black and the orange, for 240 volts. Alternatively, if you were using another voltage, you would be using the different types. There's a little hole on the side of this transformer, a little knockout, that we can pop out to run these wires out through, so that we can feed them with our voltage. This little box is made to isolate the transformer from any possible RF interference, and that is why we are using it. Some units you can do without the box, but for most instances this does keep away from the RF interference. There's a tiny little screw here which holds this cover on, as you can see. Now you have your unit completely sealed up. The cord hanging out the side of it is what is going to power the REMI unit. So we're just going to swing that out of the way for now. And we are going to mount this unit You want to find a nice space where it cannot get into anything else and short the unit out. or short out anything else in the air handler. And we are going to use the other side of the heater box for that. The unit does come with screws in the kit if you wish to drill holes through the base of the air handler and mount the transformer in an alternative position. Especially if you do not get a solid connection of the unit and it is loose in here, you definitely want to install it in a different manner, meaning drilling a few holes in it. We're going to have to add a little wiring here as our unit is not quite close enough to connect all of the wires together, so we're going to make a few jumpers for this. It does not take a very heavy gauge wire for this. I am using 16 gauge wire for what I'm going to be doing here. There are wire nuts included in the kit, so you should have just about everything you need for this installed here. We try to make sure you have everything you need in the kit, if at all possible. As I'm doing the common high voltage wire first, which is the black on this particular transformer, I am going to connect the black to my line incoming black, and where I'm going to connect this is off of the existing low voltage transformer in the unit here. I'm going to do this by use of a line tap. Alternatively, you could cut the wiring and use a wire nut. I just prefer not to cut the wiring of the unit if at all possible. I'm going to use a common snap tab that most air conditioner installers are familiar with. And all you need to do with it is find the line voltage that you're going to connect to, snap it on the line voltage like so, and then the feed, you can place it into the other side and make sure it slides in far enough so that when you close the connectors, you get a full contact all the way across. When you clamp the unit shut, it makes a connection between your existing voltage and the wiring you have added. So basically all you have to do is clamp it like so and lock it. We now have our common voltage connected to our transformer. Our switched voltage, which is going through our relay, we're going to come from our line voltage on the transformer, and we're going to power that off of terminal 4 on the relay. And in order to do that, we're going to use a standard terminal clamp. Just a regular male spade connector. And that gets connected to the orange wiring. This is our switched side of the low voltage transformer. Make sure you have a very good connection here. And this is going to be our switched leg, which turns the LED unit on and off. And we're going to connect that to terminal 4 on the relay, because terminal 4 is the common from both the other switch legs, terminal 2 and terminal 5. Okay. So that takes care of your high voltage wiring going into the transformer itself. Now we're going to do our switched voltages for this. On this particular instance, for our heat, we are going to be connecting to the opposite leg to power through the transformer to turn the transformer on when the unit turns into heat. And in order to do that, we're going to use a jumper 1/4-inch spade plug, which has a second male terminal on it, which you can use to actually add a leg to one of your heat terminals. So we're going to use the heat sequencer on this particular unit. It happens to be a relay and not an actual heat sequencer. So we're going to use that side of the power coming out of the relay in order to power the unit when it is in heat. So we're just going to use this split tap on one side and a regular 1/4-inch spade on the other to connect it to the relay on terminal 5. There are several different types of these jumpers that you can use. There are some that are just a standalone unit, or you can use the common 1/4-inch plug like this with the extra leg to connect the extra space. Some of the heat sequencer units already have a second leg on them, so you do not need to do this step. It will vary by your air handler that you happen to be doing. So we're going to place that on where our heat sequencer turns on, or in this case the relay. So this is the line voltage when the unit turns on the heat. And then we're going to take our little jumper. It's going to go to terminal 5 on this particular unit. If this was a gas unit with gas heat using a 2-speed motor, instead of connecting it to the heat relay as I have done, you would be connecting it to the low speed tap on that 2-speed motor, as that is what gets energized in heat and gives us our signal. So you would be connecting terminal 5 to the low speed relay of the fan motor on a 2-speed fan with gas heat. If you're using a gas heat unit which does not have a 2-speed motor, which has a variable speed motor, then you're going to be using our alternative air switch kit, which we will be showing you in a different video. Now, our terminal 2 on this unit is going to be connecting to the other side of the line voltage, so it will turn on when the relay is energized. Again, I am not going to cut any of the wiring in the air handler. I am going to use another one of my little line taps here. And that, on this particular unit, is going to come to the incoming to the existing transformer on the yellow on this particular unit, but every unit is possibly going to have a different color there. So that now you have your full 240 volts to feed this unit, whether it's in heat or cooling. As such. Now we're going to do the low voltage wiring on this. And for low voltage wiring, you have your terminals 3 and terminals 1. We are going to energize one of those terminals from the yellow wire coming with the thermostat to terminal 1. And what this will do is it will energize this relay anytime the unit is in a call for cooling. Thereby turning on the LED when it is in a call for cooling. Again, this is low voltage wiring here, so make sure you do not confuse your low voltage wiring with your high voltage wiring on this, or you will make some awful sparks. So we have terminal 1 now connected to the yellow wire on the thermostat. We're now going to find our common wire, which on this particular unit appears to be the brown. And so we're going to make a jumper from the brown, which is common, through to terminal 3. And again, that is connected the same exact way as we did terminal 1. So to reiterate, your control voltage from the thermostat for this is your common to terminal 3 on the relay, and your yellow wire, which energizes the contactor onto terminal 1. Now all we need to do is run our wiring out through the unit. This is an alternative thermostat wiring plug in the unit that I am taking out at this moment so I can get my end of my cord through it. The end of the cord has a kind of a large plug on it, so sometimes it's a little difficult feeding it through. And then once you have it out, it will plug right directly into the back of the LED unit, And when this unit cycles on, you will see a light right here. That tells you this unit is turning on and off. Try to neaten up your wiring a little bit. We now have our wiring completed on it. We have our unit installed. And all we have to do is put it back together. Okay, so now to cover what we've done for wiring, we've wired our transformer to be controlled by the relay. The output of the transformer connects to terminal 4 on the relay. Our line voltage on the other leg comes into the relay from our common, or in this particular instance, we use the black wire, which is the common for the 240 volts. Our yellow wire on this one is what we're using to feed our relay on terminal 2 from line voltage. And then we have coming off of the heat sequencer relay or terminator in some units, we power into terminal 5. Our low voltage, we have yellow connected to terminal 1, which is going to energize the relay anytime the unit is in a call for cooling. Our common connected to the brown, as it's common for that particular particular usage. And so now all we need to do is turn on our power, and our unit, when it's in cool, will turn on the REMI. And the unit powers up. When the energy comes on, you heard the buzz from the unit. That is normal. It will do that every time it cycles. So it is a common noise. We now have our unit in and running. And anytime the unit cycles in heat or cool, we'll turn on the REMI. We have a small LED here on the side, which you can inspect the unit to see if it is running when the blower is running. And elsewise than that, this unit is complete.